Good morning, friends. I am here again for my course, Aircraft Systems. Topic for the today class is Power Distribution System, Primary and the Secondary. As you know, my name is Dr. Dwivedhi, Professor from Institute of Aeronautical Engineering, IARE, Hyderabad, India. In this lecture, I am going to discuss about electrical, air conditioning and pressurization system. And before I have to complete this, I have to just go for a revision. In my revision, I have taken in my module 1, that is Introduction to Aircraft Systems. In that system, I have taken the 4 main topics of the systems. That is, first one is aircraft structures and airframe system. So in my this revision, I will just go what I have covered in my module 1. So in module 1, I have covered, the first one is airframe system, airframe systems. This is also called the aircraft structural then second one is vehicle system, aircraft vehicle system. Third one is avionics system. And fourth one is mission system. These all 4 I have already covered in my module 1. So you can see here that the airframe system or aircraft structural system, in this we can have 3 major things. First is the wing, another is fuselage, third one is the empennage. If you see about the wing consists of number of things like longerons, stringers, bulkheads, aerofoil, and so on. Same way, the fuselage also having different types. And empennage, if you talk about the empennage, it is a tail part of fuselage. It consists of vertical tail, horizontal tail, then third one is tail boom. These are the 3 parts which are covered in the empennage section. This I have already covered in detail and hope you have understood in my previous classes if you are not able to do that. Next, if you talk about the aircraft vehicle system. So in aircraft vehicle system, we can have the flight control system. Then second one is, we can see about the propulsion system. Third one is fuel system. Fourth one is hydraulic system. Fourth one is hydraulic system. So like this, in aircraft vehicle system, flight control system, propulsion system, fuel system, and hydraulic systems are covered. So if you talk about the flight control system, I will write here FC system. So in FC system, we can divide in two parts. That is the conventional FC system and fly-by-wire FBW system. So conventional FC system and fly-by-wire system. In olden days and small aircraft, we use the conventional flight control system, but most of the fighter aircrafts and modern passenger aircrafts also, they use the fly-by-wire system. The advantage of fly-by-wire system is that it has reduced the weight. A tremendous amount of weight of the aircraft is reduced. Very reliable flight control system. Wear and tear of the fly-by-wire system is reduced. The effort put by the pilot is also reduced. Safety of the aircraft is enhanced. So these are the few advantages of fly-by-wire system. However, the disadvantage, you can say, it's costly, needs a lot of power consumption. These things are the disadvantages. But if you see about the conventional flight control system, it is a hydraulic or hydromechanical devices. In that, the pilot has to push the rod and the different control yokes, control sticks, and the mechanical linkages by pulleys, wires and all. It is transmitted to respective flight control system. In this way, the flight control is achieved. This is not so good, and nowadays this is mostly obsolete, and most of the aircrafts are now using fly-by-wire. In conventional, due to the wear and tear of this mechanical linkages and bearings and all, it becomes stiff, and operation of the flight control systems are sluggish, and it is somewhat dangerous to fly the conventional flight control system. So this is about the flight control system. Now if I talk about another system of this thing is propulsion system. This one. So propulsion. So propulsion means some engine is required to give the thrust. So we can divide this propulsion system into two parts. One is the reciprocating engine. Reciprocating engine or piston engine. Second one is rotary engine. Rotary engine. This is also called turbo engines. Turbo engines. So in this, reciprocating engines are used for a small aircraft nowadays. Small general aviation aircrafts, not very efficient for high altitude. They can be used for training or some recreational or some other purposes. However, if you want to fly the high speed aircraft or the big passenger aircraft, we need the turbo engines, and in turbo engine we have the turbo shaft engine. Then we have turbo prop engine. Then we have turbo fan engine, and we have turbo jet engine. So these are the few engines which are used in different types of aircraft for different purposes. Now if I talk about the third system of aircraft vehicle system, the third component is we can see that this is the aircraft fuel system. If you talk about the fuel system, I will write here fuel system. For every engine, we need some fuel. This fuel has to be circulated in a proper way as per the requirement of the mission and the different maneuvering and the different flight conditions. The engine should get sufficient required amount of fuel. Then only engine will be able to produce the power which is required for the engine. So we can divide this fuel system into again two parts. One is the aircraft fuel system. Aircraft fuel system and engine fuel system. Aircraft fuel system and engine fuel system. We can divide in these two categories. So if I talk about the aircraft fuel system, so in this, just before the engine, the fuel is coming from the aircraft tanks. Mostly the aircraft tanks are located in wings and belly of the fuselage. From there, with the help of the fuel pump, booster pump, different valves, different sensors, it has to go to the engine. So from the tank to the engine, the fuel system which is in this area is called the aircraft fuel system, and as and when it is entering the engine, from that point onwards, the system which is used for the operation of the engine, different types of pipelines, non-return valves, shut-off valve, engine-driven pump, fuel governor, and so many idling device, torch igniters, different items are there for different systems that I will be discussing in due course of time as and when this system comes in different units. So now I will go to this last of this aircraft vehicle system, that is called the fuel system, is over now hydraulic system. So in this revision, the hydraulic system is used to operate for different emergencies, different flight control systems, landing gears, opening of doors, and so many other components are operated by hydraulic. And basically the hydraulic systems has one booster pump which is normally fitted in the engine, on top of the engine. From there, a high pressure hydraulic fluid is pumped to the different operation of different things, and it is moving with different pressure reducing valve, pressure relief valve, non-return valve, pressure sensors, and so many other components. As per the requirement of the system, it will move for different systems. Now if I talk about the avionics system, so this avionics system has main thing, the communication system, communication, navigation, and third one is some miscellaneous system. So these avionics systems are used to communicate from pilot to ATC, from ATC to the pilot. Also for navigation purpose, how to find the direction of the aircraft, how to reach to the next destination, how to navigate, how to land the aircraft in a safe way. This things comes under navigation. And if you talk about the miscellaneous system, in this different electromechanical systems are used for in conjunction with avionics systems like head-up display, helmet-mounted display, and so many other electronic devices for passenger and military aircrafts. Now, next, if I talk about the mission system, in mission system, every aircraft is operated for different missions, and for that mission, aircraft has to perform the given mission. Like one helicopter is used for search and rescue. It is called search and rescue. Then armament delivery. Armament delivery. Missile system. Then ASW, anti-submarine warfare, mapping of area, and so many other missions, flood relief, other things we can do by the help of this mission. And these mission systems are mostly used on military aircraft, not in the civil aircrafts. So this introduction part I have covered in my module 1. Now I am here for my module 2, and in this module 2 I am going to talk about these topics which are mentioned here. This you can see here. Okay, so here we have air cycle refrigeration system and its basic principle. So how this air cycle refrigeration systems work? In this basic principle, types, turbofan refrigeration system and bootstrap system. If you talk about environmental control system, in this reverse bootstrap and ram power reverse bootstrap, we can use in this type of system. So why we need air conditioning and the pressurization of the cabin? So we know that the human is designed for a certain pressure and temperature, certain pressure and temperature. Your aircraft is also designed for certain pressure and temperature. So as and when your aircraft is going to in high altitude, it is a sea level. I am 1 atmosphere, and as you go higher and higher, here pressure reduces, density of air reduces, temperature reduces in the. So as and when you go up, the pressure is falling down of the atmosphere, and the human being and the aircraft itself, there is a huge amount of pressure difference between the atmosphere and inside, and there is likely to be problem for the passengers, the pilot, the air crew. Also for avionics equipments, they are operated for a certain range of pressure. In that, they perform a best result. So in that only it will work good. So we need to have a controlled temperature inside the cabin or inside the fuselage, so that, and also a required amount of temperature has to be maintained inside the cabin, so that a required comfort and a good amount of your navigation and communication or avionics equipment has to work efficiently, and this will only work efficiently if the temperature is given in the designed if the systems are working in a required temperature and pressure conditions. So here we have turbo environmental control we have to use, means we need sufficient amount of oxygen, sufficient amount of air for our breathing. So in that we use the reverse bootstrap, ram powered reverse bootstrap. These are the methods which we use for this purpose. Now I will discuss about environmental control system of aircraft. So environmental means how we can control the air, the oxygen, a clean environment, plus required pressure and temperature and the required density inside the fuselage, how we are able to handle and how we are able to maintain such a atmosphere inside the aircraft. They must be neither too hot nor too cold. They must have air to breathe, and they must be kept in comfortable atmospheric pressure condition. So if you see here, too hot and too cold, the human efficiency will be reduced, and also the component efficiency of the aircraft will be reduced, especially the avionics system. They should have a proper air to breathe. The pilot, the air crew and other passengers have to have a sufficient amount of air and sufficient amount of pressure, so that they can breathe nicely and they can work nicely. They must be kept in comfortable atmospheric pressure conditions. So the pressure should be very much required, otherwise people will not feel comfort. Very discomfort people will feel. Aircraft may be designed to perform in climatic extremes ranging from Arctic to full desert sunlight. So your aircraft should be designed to plus 60 to minus 150 degrees centigrade. So in this means hot like deserts and cool like Antarctica, your aircraft should be able to fly. The human cargo be subjected to extreme of discomfort. Passengers will go to another airline and the military crew will not perform at their most effective. So why we need? So if you are not able to maintain a very comfortable condition, the passengers which are traveling in your aircraft will not come to your aircraft next time if they are not comfortable. They will go to the other aircraft, and if the military persons, they are flying the military aircraft as a cargo aircraft, fighter aircraft or military helicopter, the pilots, the air crews, the observer, the flight engineers has to have a comfortable conditions inside the aircraft. Otherwise, their mental ability will be degraded and their effectiveness of the performance will be tremendously reduced. To avoid this, either it should be the military aircraft or it is a passenger aircraft. In both conditions, your aircraft should maintain a very extremes of discomfort. Means at any type of climatical changes, the air inside the aircraft, the effective pressure, temperature and the required density has to be maintained, so that the efficiency of the aircraft is increased. the efficiency of the air crew and the staff of the aircraft is increased. The efficiency of the avionics equipments and other equipments, those who are inside the aircraft, has to function well. So the environmental control system must cope with widely differing temperature conditions, must extract moisture and provide air with optimum humidity, and must ensure that the air in the aircraft always contains a sufficient oxygen. So, it must ensure that the air in the aircraft always contains a sufficient amount of oxygen. The need for a controlled environment for crew, passengers and equipments. Due to high performance of aircraft nowadays, environmental control systems is needed, which provides favorable environmental condition to instrument and equipments, pilots and crew, passenger and the cargo. So why we need the environmental, a controlled and required environmental condition? So instruments and equipment should work efficiently. Pilots and crew should also work at their best efficiency, and the passengers and the cargo. The cargo, if it is perishable, like flowers, vegetables and all, they should be maintained a proper temperature so that your aircraft is able to maintain a proper condition. So in this way, these things are required, and for this, instruments and equipments, pilots and crew, passengers and cargo, this has to be in a controlled environment, and this is obtained by some systems. So heat sources in aircraft. From where we are getting the heat in aircraft? So that we have to first understand, then we can go further. Kinetic heating occurs when the aircraft skin heats up due to friction between itself and air molecules. The skin in turn heats up the interior of the aircraft, such as the cockpit and equipment base, can reach to 100 degrees centigrade. Solar heating. Solar radiation affects a military aircraft cockpit directly through the windscreen and canopy. Equipment base and civil aircrafts are only affected indirectly. So, solar heating. First, the kinetic heating. Kinetic heating occurs when the aircraft skin heats up due to the friction between itself and the air. So, the aircraft is moving very fast. So, due to the high speed and the molecules of air is striking to the skin, and skin is getting heated up. The skin in turn heats up the interior of the aircraft, such as the cockpit, and the equipment's base can reach up to 100 degrees centigrade. So this much temperature it can increase. So this is the kinetic heating, means due to the motion of the aircraft. Now solar heating, it is due to the solar radiation, the radiation which is achieved from the sunlight. Solar radiation affects a military aircraft cockpit directly through the windscreen and canopy. Equipment base and civil aircraft cabins are only affected indirectly. Okay, so in this affect military aircraft, in military aircraft, this is coming directly to the pilot, and equipment base and the civil aircraft cabins are only affected indirectly. So for the civil aircraft, most of the things are kept in the controlled spaces. Avionics heat loads also generates. Your avionics are operated by the help of the electrical loads, and these electrical loads are taken, and this generates heat, and this heat again increases the temperature of the surrounding inside the aircraft. The temperature of this thing will increase. Airframe system heats and the loads. We have a lot of airframe systems, like I have just now told that flight control system, your fuel system, hydraulic systems, oil systems, pneumatic systems, firefighting systems, all are operated by the help of the pumps. These pumps are operated by electrically operated or by any other means, and they generate some amount of heat, and this heat is retained inside the aircraft. So the need for cabin conditioning. First we have to see that why we required a required temperature in the cabin where pilot is sitting. So the cockpit is affected by the source of heat described as I have explained above. But a high performance fighter is particularly affected by high skin temperature and the effects of solar radiation through the large transparency. Because if you see the fighter aircrafts, the canopy on top of this is full of glass screen and it is flying very high altitude. So the effect of sun radiation is very high, and also due to high velocity, the skin temperature is becoming very high due to shock wave formation. The temperature is increased very rapidly, and this is transmitted inside the aircraft. So for designing, we must know what the pilot bearing in cockpit. So the easy at what sea suit canopies always have solar radiation. Canopies and the wind screen. Pilot workload are high stress. So these are the things for which we need the cabin conditioning. So what for? So first is cockpit condition. It should be very good because cockpit is always affected by that. Then must have the pilot bearing in the cockpit. What type of suit? The cloths pilot is wearing inside. Canopy and the windscreen. What type of canopy is there and what type of the windscreen? The glass is there. Pilot workload or high stress. So workload, how much workload, and accordingly we have to plan what type of air conditioning should be there inside the aircraft. All these factors make it very difficult to cool the pilot efficiency so that his body temperature is kept at a level that he can tolerate without appreciable loss of his functional efficiency. So we must ensure that the pilot should not lose its mental balance and he or she should be able to fly with a very comfortable state of mind, and this can be only achieved once the atmospheric environmental condition inside the cockpit is very, very good to operate the aircraft. So I am going further in the same topic. The maximum temperature at which semiconductor components can safely operate is above 100 degrees centigrade. Although prolonged operation at this level will seriously affect the reliability. You know that at high speed aircraft, their skin temperatures can go nearly 100 degrees centigrade. However, your semiconductors can work very nicely, but if it is exposed to many hours, then it is likely to be damaged. Air conditioning systems are typically designed to provide a maximum conditioned bay temperature of 70 degrees centigrade. The minimum design equipment's operating temperature for worldwide use to be about minus 30 degree. So maximum is 70 degree and minimum is minus 30 degree centigrade. Equipment must also be designed to remain undamaged over a wider temperature range, typically from 40 degrees centigrade to 90 degrees centigrade for worldwide use. So the international standard atmosphere, what is that? So for air pressure, it should be 101.3 kilopascal absolute. Air temperature is 15 degrees centigrade. It is a international standard temperature, and the sea level density is 1.225 kg per meter cube, not meter. It is a kg per meter cube. So an international standard atmosphere has been defined for design purposes. Okay, so here you can see the plot of a density ratio versus altitude in 2000 feet. If you see at sea level at 0, you have very high density. As this, it is altitude is increasing, then density is decreasing. So both are, if you increase the, or you go at a high altitude, the density you see here at Earth or the sea level, you have the 1, but if you go to some 80,000 feet or 60,000 feet, it is 0.1. It is very, very less. Very thin air is available. Density less means very thin air. If you see the ambient pressure also, it is like the same only. So at 0, you have 1.225, and as you increase the altitude to 100,000 feet or 80,000 feet here or here, it will be, pressure will be almost 0 if you go 100,000 feet of altitude. So like this, we have to see that this is calculated, and we should be able to understand these parameters. Now I will go for environmental control system design. In this, we have ram air cooling. How these things are done? The use of ram air is a cooling medium has its limitations. Since ram air temperature increases with air speed and soon exceeds with air speed and soon exceeds the temperature required for cabin and equipments. Okay, so here this you can see in this diagram that here is a heat exchanger. In heat exchanger, if you see here some pipes are there like this, like this, like this, and it is connected to this. It will enter from here and it will exit from here. Charge air, ram air, it will go from here and it will go inside this and it will cool it, and it will go jet pump flow from ECS primary fluid. So here this is a fan, and this fan will blow air in this direction. So air will enter from this side to this side, the direction of air. It is called the ram air, and in this way we can cool the aircraft. If you want to cool the oil cooler, so how we can do? The same way here, oil is entering from this side, it is going like this, coil, and it is coming like this. Air is coming from this side and it is sucked by the engine and your fuel cooled oil. So in place of oil, we use the fuel here, not air, sorry. It is fuel is coming from the fuel tank, and this will go via this thing, and here the oil which is used for lubrication of engine bearings, and it is hot oil. This hot oil is entering here, and this hot air is cooled by the fuel. So oil and engine oil is cooled by the help of the fuel which is used to give the power for the engine. And next we can see here engine bleed. The engine bleed also is used. The main source of conditioning of air for the both civil and military aircraft is engine bleed from the high pressure compressor. This provides a source for the civil and military aircraft. In engine bleed from the high pressure compressor, this provides a source whenever the engines are running. And this air, just you see here, this is from the engine. Here is the engine. From the engine, some air is bled. This engine ram air is coming from here, air cooled fuel cooler. So here it is coming, the fuel, and fuel is going, and the air which is entering here, and fuel is in this direction. This is the fuel direction, this side. So this air cooled and fuel is used. Here air bleed from the engines are used as an ejector, and this ejector will suck this air. This is sucked by ejector. So this high velocity air is going, so here the pressure will be reduced and this will be sucked. So in this way these systems are working, and this engine bleed is used for this purpose. Now mixing hot air with heat exchanger outlet. This also we have to see that in aircraft we have to maintain required temperature, required pressure. We need different types of heat exchangers. Heat exchangers are used to cool or hot as per the requirement. So this you can see here that pressure reducing valves, hot air from the engines are coming and they are coming to here, and this is ejector here. Ejectors are here, and here this ejector will eject here in this direction, and this will make here low pressure. This low pressure, it is coming from here and it is going from this by the heat exchanger, and it is again going for the different line. So here, if this is the 100 degrees centigrade, here you may get 30 degrees centigrade. That much is cooled by the help of the heat exchanger, and this flow is maintained by the help of the pressure, hot air extracted from the engine, and this is going. And here the ram air. Ram air is a free air which is used in aircraft during the motion. You get a sufficient amount of air. So in this way, your heat exchangers are working in aircraft. Now I am going to talk about the refrigeration system and how this refrigeration is taking place. So air cycle refrigeration systems are used to cool engine, bleed air down to temperatures required for cabin and equipment conditioning. Since engine bleed air is generally available, air cycle refrigeration is used because it is the simplest solution to the cooling system. We use the air cycle. Why we use the air cycle? We use the air cycle refrigeration because the air is available for aircraft abundant. There is no shortage of air. So if we use the air, it is good for the aircraft and it gives a very good efficiency, because in this we don't have to carry any refrigerant. Only air is used as a refrigerant. So air cycle refrigeration systems are used to cool engine, bleed air down to temperatures required for cabin and equipment conditioning. Since engine bleed air is generally available, air cycle refrigeration is used because it is the simplest solution to the cooling problem, fulfilling both cooling and cabin pressurization requirements in an integrated system. So if we use the air, it can be used for the cooling, also cabin pressurization, and also for the taking breath. However, although lighter and more compact than the vapor cycle, it is lighter but compact. Air cycle systems have their limitations. Air cycle has got some limitation. Very large airflow are required in high heat load applications, which require large diameter of ducts with the corresponding problem of installation. So these are the issues. So for the air cooling, we need a very big equipments and a large diameter of ducts are required, and the installation, a big amount of installation is required for this type of system. So what is the principle behind this? How this refrigeration is working? A source of high pressure air is cooled as much as possible in the heat exchanger using ram air as a coolant. The air is then expanded across a turbine to reduce the temperature and pressure further. The turbine drives a fan or the compressor which acts as a brake while doing work, forcing ambient air across the heat exchanger. Examples of such systems are described below. So here we can see the turbofan refrigeration system, how these things are working. This will typically be used in a low-speed civil aircraft where RAM temperature will never be very high. So this RAM temperature is very high for a low speed aircraft. So here, this you can see here, in this we need a turbine. Just you can see here turbine, we need a fan, and you see that coolant air is coming from here, and charged air, pressurized air is entering here, a somewhat high pressure and high temperature, and a cool air is coming from this, it is entering from here and it is going in this way, and the air which is coming here, we have the heat exchanger, number of coils are there, this is passing from this coil, and then this goes to this, and here it is going to a turbine, and this high pressure air are entering in the turbine, and here further temperature is lowered. Temperature is lowered for air conditioning purposes. Okay, so and here is a fan, and this fan makes the air to blow in this direction. So this is rotated, and this is rotating turbine is rotating this fan, and this will create a suction here. So in this way, the both are utilized. The energy which is used, it is utilized for both the systems. So now I will talk about the bootstrap system. So what is the meaning of bootstrap? Conventional bootstrap refrigeration is generally used to provide adequate cooling for high RAM temperature condition. So conventional bootstrap refrigeration is generally used to provide adequate cooling for high RAM temperature conditions. For example, a high performance fighter aircraft. In high performance aircraft, we use the bootstrap system. It consists of cold air unit and a heat exchanger. Turbine, the compressor is used to increase the air pressure of a cold corresponding to increase in temperature. The temperature is then reduced in the ram air cooled heat exchanger. This reduction in temperature may lead to water being condensed out of the air, especially when the aircraft is operating in a humid climate. So this type of bootstrap, in this, what we do is, the air is in primary heat exchanger, and from here, here the ram coolant air, here the water extractor is there. So this air is, this compressor is rotated, this will rotate the turbine. Here if water is there, it is extracted, and bleed air is coming from here, and this goes cold air unit bypass. So here it will be hot and cold, it will come, and here is the cool. So as per the requirement, here it goes to the avionics and other systems. So this is called the bootstrap. So in this we have compressor also and turbine also, and also we have the primary heat exchanger which used for heating and the cooling, and this is very compact and used for a high performance fighter aircraft. This type of systems are used. Now the previously we have discussed only the temperature and the pressure, controlling of the temperature and the pressure, but now we have to see that how the sorry how this environmental of the aircraft is controlled. That is also very important thing. So here this water extractor at the turbine inlet, which will remove the most of the free water, helping to prevent freezing of the turbine blades and water being sprayed into the cabin and equipment base. As the air expands across the turbine, the temperature can drop below 0 degrees centigrade in certain flight condition. So this is the, this you can see here that here is a fan, efficient air conditioning system, and it is here HP bleed air from the engine, high pressure and here the low pressure, both are going here. Then it goes to the shut-off valve. From here it goes to the temperature selection, it will give here. Then it will go to dual temperature control valve. So this will control the, and here this opening of this, as per that it will go here. In this line is visible here. And then it will come here. Here is a turbine, compressor and turbine is here. It is further, it is operating a fan here, and water injection is given for a further cooling here. So here the water which is extracted from turbine is used here. You see, in turbine we are extracting the water and there it is sprayed. So it is further cooled. So it is multiple way your air is cooling, and then it is going in this way, and this goes to the cabin temperature switch. Here as per the design temperature, this will maintain and this will go to the cabin or different requirements. Okay, so in this, very good, it is called bootstrap because the extractor of this turbine is used to operate the fan, and the extracted water which will be sprayed by the help of this thing to further cool the air. So it is used to give a very efficient system. Here the temperature selection switches and some electronics are there, cabin temperature sensors, and here different ram airs are used for this purpose. So hope this will be cleared for you all. So further I think reverse bootstrap. So we have done the bootstrap. Now it is the opposite to the bootstrap. Here charge air passes through the turbine. Charge air passes through the turbine of the cold air unit before the compressor. Following initial ram air cooling from a primary heat exchanger, the air is cooled further in a regenerative heat exchanger and is then expanded across the turbine with a corresponding degree in temperature. Okay, so just you can see here how these things are working. So here just you see flow is coming from here. It is a primary heat exchanger. This air is used to cool this air, and then it will enter to regenerative heat exchanger. This will go to the compressor and the turbine. Again this cooled air will again enter here, and this will go to the heat exchanger. Here the radar, heat load and other things will be removed. So it is called the reverse bootstrap. So in this further efficiency of this systems can be increased. Now this ram powered reverse bootstrap. A ram powered reverse bootstrap air cycle system can be used to meet such standalone cooling requirement for military aircraft. The method increases the capability of ram air cooled by expanding the ram air through a turbine, so reducing air temperature as shown in this figure. Cooling can be provided up to much higher air speed than a purely ram air cooled system. Cooling is still problem on the ground and at low speed. So in this, on the ground you cannot do, and it will create the problem. So these systems, you can see that ram air is entering the turbine. Turbine is rotated. This will also rotate the compressor. Compressor will increase the pressure, and this cooled air will enter here. Again it will go to the heat load, and it will cool here and it will go here, and again this process will continue. So this ram powered reverse bootstraps are not very good for low speed aircraft, but for high speed aircraft these are the good alternative. In the next class I will be discussing about primary power distribution, power conversion and energy storage, transfer rectifier units, batteries, secondary power distribution and load protection. This will be discussing in my next class. And in today's class, hope you have understood that how the environmental of the aircraft has to be maintained, and as per the environmental condition, the pressure and the temperature of the aircraft has to be maintained so that the efficiency of the aircraft is maintained well. So I am taking the references from Moyer I and Seberg A aircraft systems, mechanical, electrical, and avionics systems, professional engineering publishing. And the second book is also from Moyer and Seberg, a design and development of aircraft system and introduction, AIAA education series, AIAA 2004. These are the books which I am referring for this class. I have taken the notes from here, and I thank to the author of this for providing such a nice and wonderful material. Any questions, you are welcome to ask. My email is ydwivedi@gmail.com. You are welcome to ask any questions in this, and thank you very much for joining this class. I will be again coming for my next class. Till then, see you and take care. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.